Hello everyone, I am Abhijit Urde. Today we are discussing about rectifier speed control of DC motor. Now this is the block diagram of single phase DC drives. In this circuit we can see this is the field winding and this is the armature winding. If the armature circuit of DC motor is connected to the output of single phase control rectifier, the armature voltage can be varied by varying the delay angle of the converter alpha. The forced commutator AC/DC converters can also use to improve the power factor and to reduce the harmonics. To control the speed of DC motor, there are various techniques used. In that, we are mainly focusing on rectifier control the DC motor, rectifier control the speed of DC motor. In that, we are mainly focused on first three methods: single phase half wave converter drives, single phase semi converter drives, single phase full converter drives, and single phase dual converter drives. Now we move forward. Single phase half wave converter drive. This is the circuit diagram of single phase half wave converter drive. In that, field winding is same for all connections, but only difference in armature winding. In a half wave converter drive, only one SPR is present, and prevailing diode is used to prevail the circuit. Suppose our VS is sinusoidal wave. When during positive half cycle, when switch is on, then current flowing through this path RA, LA, EA, and when switch is off, then current flowing through this freewheeling loop. So our output current is always continuous, but only change in voltage, because the switch output voltage depends on the working of switch. Means when trigger pulse is applied, then only switch is on, and when no trigger pulse is applied, then switch is off. So now we are going to see the output waveforms of the circuit. This is our input voltage, sinusoidal wave Vm sin omega t. Now output wave is looking like this. The output V out is high only when switch is on, but switch is on at a particular firing angle. After that, suppose our firing angle is 30 degree, then after 30 degree switch is on, and alpha plus pi plus alpha, our output is up. Then we can clearly see here, after firing angle our switch is on, and at that time output voltage is high, and during negative half cycle our output is low. And now this is the output current, current output current waveform. Our output current is continuous. We discussed it earlier, and this is prevailing current. When switch is on, then prevailing current is low, and when switch is off, then prevailing current is high. Now this is the single phase semiconductor drive. In that, two thyristors and two diodes are connected, uh, but in this case only at a time only T1 and D1 is on, and T2 and D2 is on. During positive half cycle, current T1 and D1 is on, then current flowing through loop T1 RA, LA, and D1, and during negative half cycle also we get the output waveform. Now this circuit works in both positive and negative direction, and prevailing diode it helps to uh, give continuous current. Means if T1 is closed, and we want continuous current, then at that time inductor start discharging the current, and current is flowing through loop in this prevailing loop. So this is prevailing diode helps a lot to give continuous current. Now output waveforms are This is our input Vs, VM7 movement device. We discussed that output current is high, output current is continuous, and this is circuit current, and this is source current. If we go circuit current is continuous, but source current is discontinuous, because at when switch is open, when switch is on, at that time only we get high current, and means this is happen only at when T1 and T1 is on, and when T2 and T2 is on, at that time we get negative current, which uh, which uh, which helps to operate in both positive and negative half cycle. This is freewheeling diode current. When we know, when switch is on, then freewheeling current is low, and when switch is off, then freewheeling current is high. Single phase full converter drives. In single phase full converter drives, all the lower half two diodes are connected, replaced by also by thyristors. So it consists of all four thyristors, which helps to remove the freewheeling diode when input voltage is applied Vs, and during positive half cycle when T1 and T2 is on. Now, also in this case, at a time T1 and T2 or T3 or and T4 is on. Not all the four thyristors are on at a time. So when T1 and T2 is on, at that time the current flowing through this loop T1, RA, LA, EA, and T2. And during negative half cycle also we get the output current and output voltage. Now output waveforms are, this is our input sinusoidal wave. Now we know for current, we get continuous current, because at when T1 T2 is on, at that time voltage across the load is current across the load is at the up to the mark, and also when T3 and T4 is on, at that time also we get current, so we get continuous current. In case of source current, source current is get after source current is high only when switch is on, and it is in a negative half when T3 and T4 is on. Means if T1 and T2 is on, at that time our current source current is high, and at T3 and T4 is on, then our current is in negative half. This is happen when, by firing angle phase shift, means uh, it goes in negative half after pi plus alpha phase shift. Thank you.